Welcome. This is the July 2021 update on Solar Cycle 25. We've been in this cycle now for a total of 19 months, and the cycle is continuing to build. The best news of all is that HelioViewer is back, or at least partially, and so we can show you movies once again of what's going on the sun. The sunspot number is overall increased. We did get the first spotless day in 83 days. That's the longest run since March of 2016. We've had some spectacular flares, particularly at the beginning of the month. Geospace has been particularly quiet. The sun is basically a magnetic variable star. So we can take a look at the HMI magnetograms. The thing to look at is the magnetic regions crossing the sun. These are the large areas of black and white shown in the video. The ones that are likely to produce sunspots are the large ones, the intense ones, and those that are rapidly growing. And those latter two are also good signs of potential flaring. Note as the regions cross the disk how they grow and change. As a region gets older, it gets stretched out and weaker. New regions grow rapidly initially and then go into a more stable phase. Next, we turn to sunspots. One of the things to look at this movie, do you see any returning regions? Or how do you know when a region is returned? Well, they appear about 2 weeks after they disappeared over the west limb, that's the right-hand limb, on the eastern limb. So that's what you look for. Sunspots will emerge, evolve, and decay, just like the magnetic regions which they are associated with. This is the sunspot movie. To give you some idea of scale here, the little inset at the top right is a disk that is the size of the Earth. Now let's take a look at how far Solar Cycle 25 has progressed. The plot we have here is the number of sunspot regions emerging over time. And you'll see that July of 2021 on the far right is one of the more active months. We had 20 new sunspot regions emerging during July. All of them were Solar Cycle 25 regions. There were no Solar Cycle 24. Solar Cycle 25 regions here are shown in orange, and Solar Cycle 24 regions are shown in blue. And you can see there's no blue in July. If you go to the Solar Influences Data Center plot of sunspots as a function of time, we have here the yellow is the daily record, blue is the monthly average record, red is the record that people pay attention to, which is the smoothed average. We take a 13-month smoothing of the monthly sunspot number. That gives you the red curve. And then the dash curves on the right are various sunspot models. And you can see that the Solar Cycle 25, which started in December of 2019, has been rising quite quickly compared with its previous cycle, Solar Cycle 24. And this last month record surpassed the values from the previous 4 months. We did have one spotless day, which was the 30th of July. However, I looked at the sun on that day and got this picture, and I could see a sunspot group there of 4 sunspots. So I'm not quite sure what they're thinking about. That number should be 14. We're often talking about just the photosphere of the sun and sunspots, but let's move up in the atmosphere a little bit into what's called the transition region. To do this, we look at the SDO AIA instrument 304 channel. This is a helium-2 channel. Its average temperature is about 50,000 degrees. So it's sort of between the temperature of the photosphere, which is about 5,700 degrees Kelvin, and the corona, 1 million degrees Kelvin. Now, on this image, what you want to do is look for eruptions from above the limb and on the disk. The bright areas on the limb are called prominences. They often erupt. And on the disk, those dark channels are called filaments. And they are the same thing, and they erupt as well. And they often produce coronal mass ejection. I'll try to point out eruptions as they go along. There's about to be one in the northeast. That's the upper left. Here it goes, there. And there's another one just east of Sun Center, there. You're probably going to have to run this video through a couple of times to see them all. Next, we'll take a look at the quiet sun, or the so-called quiet sun, because I don't think it's particularly quiet. To do that, we're going to use the Solar Dynamics Observatory AIA instrument in the 171 channel. And this channel is particularly good for looking at loops. These are cool loops about 650,000 degrees Kelvin, so they're the low temperature corona. You can see the loops that are joining sunspots within an active region, and you can see large scale loops that join different active regions, and that often can precipitate activity as a result. But also the overall structure of the corona is changing continuously, and it's often referred to as the restless sun. And as I say, this is the quiet part of the sun. These bright regions here are called active regions. They correspond to the magnetic structures and the sunspots that we've seen in the previous two movies. You can see that even the areas away from there are changing all the time, but more importantly, you can see large-scale loops everywhere. Next, we'll take a look at coronal holes. These are often overlooked in most activity discussions. To do this, we'll look at the SDO AIA 193 angstrom channel, which has a temperature about 1.2 million degrees Kelvin. A coronal hole is a dark area within this emission, so there's a lovely coronal hole in the middle of this picture. They are dark because they are low density and low temperature, and the field lines are consequently open. Open field lines are the source of high-speed solar wind. So if the solar wind stream from one of these coronal holes should hit the Earth, we're likely to get a disturbed magnetosphere or a geomagnetic storm. The other thing to look for is the two polar coronal holes. They're important in the overall solar cycle process. For the most part this month, the coronal holes have been relatively small and weak, apart from the two that are near the pole. Here's the strongest one we saw, just reaching the western limb. That's when they're most geo-effective, but otherwise we've only had relatively weak coronal holes to deal with, which is why geospace has been so undisturbed. Moving to higher temperatures yet again, we are looking at active regions. These are the X-ray regions that sit above sunspot regions. They appear bright in these images. This image is a Solar Dynamics Observatory AIA image at 335 angstroms. Its characteristic temperature is 2.5 million degrees. So this is genuine corona. Bright areas, as I said, are associated with sunspot regions, and so dynamics in these regions indicate flaring. As these regions cross the disk, you'll see some of them flashing. Those are flares. The smallest flashes are probably B flares, larger ones C flares, and the very, very bright ones will be M and X flares. And there are some of those that occurred in the northwest right at the very beginning of this movie. Did you catch them? Next, we'll deal with what you've all been waiting for, which is flares. For that, we look at the Solar Dynamics Observatory AIA instrument's 94 angstrom channel, which is at a temperature of about 6 million degrees Kelvin. Note for the flares on the northwest limb early in the video. These are the X and M flares that characterize July of 2021. Look to the upper right to see the three big flares that characterize this month's burst of activity. You might have to run through the video a couple of times to catch it. There are other flares, C flares mainly, that you see working on here, but those are the ones that we will look at in more detail. There were 4 signature flares in July. There was an M2.7 at 0717 UT on the July the 3rd. About 7 hours later, there was an X1.6 flare. That's the first X flare of solar cycle 25. And just 3 hours after that, there was another M flare, an M1 flare. Early the next day, there was an M1.5 flare at 509 UT on the 4th of July. Okay, let's look at some flare statistics. This first graph shows the number of flares as a function of time. You can see it's the third most active month from that point of view, with 28 flares total. But the important thing is there were 3 M flares and an X flare during that time, which makes it a much more active month. It, as I said, had had the first X flare of the cycle, plus 3 M flares, which you've seen now. And then I've developed something which I call flare power, which is 100 times the number of X flares, plus 10 times the number of M flares, plus the number of C flares. And you can see that July of 2021 was by far the most powerful flare productive month so far this cycle. But the general trend is distinctly upwards. So we can expect a lot more flares soon. One of my favorite things is coronal mass ejections, but unfortunately HelioViewer is not yet working for the SOHO-LASCO data yet. If it does come online later, I might create a separate video just showing the CMEs from this particular month of the cycle. The Cactus CME database lists 74 events during July. That's an increase over June's 57 events. So not only are flares increasing, but also coronal mass ejections are increasing at the same time. That is not surprising. What perhaps is surprising, that with all this activity going on the sun, that we haven't had more geomagnetic events. We've only had 3 disturbed periods, that's KP index of 4, during the whole of this period, and we've had no geomagnetic storms. So what can we conclude from all of this? The solar cycle 25 is building steadily. The number of sunspots, CMEs and flares are increasing. There's no sign of any cooling down on the sun or a grand solar minimum. So until next time, stay safe and goodbye.